The building material under your feet right now is stronger than concrete, costs almost nothing to produce, and can stop a bullet. 65% of the soil on Earth can be turned into structural blocks that outperform the cement industry's best products. The process requires no firing, no kilns, and releases practically zero carbon. Someone just forgot to tell the construction industry. In 2024, while the cement sector dumped 1.6 billion metric tons of CO2 into the atmosphere, a handful of engineers in Mexico, South Africa, and India kept pressing dirt into blocks that sea-tested stronger than the concrete standard, dried in the sun, and cost 20% less than conventional masonry. This isn't experimental. A Mexican social enterprise called Échale has built 30,000 complete homes and renovated 220,000 more using nothing but compressed earth. That's 250,000 housing units constructed from the ground beneath the construction site. The technical term is compressed earth block, but the concept is older than the Roman Empire. You take soil, you add a small amount of clay and sometimes a stabilizer, you compress it at around 3,000 pounds per square inch, which sounds industrial until you realize a manual hand press can achieve that with a lever and body weight. The block comes out dense, uniform, and ready to cure. No furnace required, no fossil fuels burned, just pressure, time, and dirt. Here's what nobody mentions when they talk about sustainable construction. 1 ton of cement produces nearly a ton of CO2. Not from burning fuel to heat the kiln, though that's part of it. From the chemical reaction itself. When you decompose limestone to make Portland cement, carbon dioxide is a mandatory byproduct of the process. The chemistry doesn't allow a workaround. Cement is responsible for 8% of all human-caused carbon emissions on the planet. If the cement industry were a country, it would rank as the 4th largest greenhouse gas emitter on Earth, sitting right behind China, the United States, and India. Compressed earth blocks sidestep that entire equation. Some formulations use 4 to 8% Portland cement as a stabilizer, which gives the blocks water resistance and structural integrity for load-bearing walls. Others use lime. Some use nothing at all, relying purely on the clay content in the soil to bind the material during compression. Even the stabilized versions reduce the carbon footprint by an order of magnitude compared to conventional masonry, because you're using a fraction of the cement for exponentially less environmental cost. The performance numbers are difficult to argue with. Standard concrete blocks in the United States are required to meet a compressive strength of 1,900 pounds per square inch. Compressed earth blocks, depending on soil composition and stabilization method, routinely hit 2,000 to 3,000 pounds per square inch. In controlled testing, certain samples have reached 6,500 pounds per square inch. That's more than 3 times the concrete standard. The blocks are also fireproof, which makes sense because you're essentially building with stone. They're soundproof due to mass and density. Bullets don't penetrate them. Insects can't eat them. Mold won't grow on them. Termites have no interest. You're left with a building material that performs better than the products currently dominating the construction market. Costs less to produce, uses local materials, requires minimal energy input, and generates almost no emissions. The question isn't whether this works. The question is why you've never seen it on a construction site. The production process is straightforward enough that communities with limited infrastructure have been scaling it for decades. Soil composition matters, but not as much as you'd think. The ideal mix is roughly 75% sandy soil and 25% clay. Sandy soil provides structure and reduces shrinkage. Clay acts as the binder. If your soil is too sandy, you add clay. If it's too clay heavy, you add sand. Engineers have tested thousands of soil types and found that 65% of Earth's soils fall within a usable range without modification. The dirt is already there. Once you have the right mix, you dampen it slightly, load it into a press, and apply pressure. Manual presses exist that can be operated by 1 or 2 people with no electrical power. Mechanized presses, running on minimal electricity or diesel, produce 240 to 480 blocks per hour. A small work team can manufacture all the blocks needed for a house in 2 to 3 days. The blocks then cure in open air for anywhere from 1 to 4 weeks, depending on whether stabilizers were used. After curing, they're as water-resistant as fired brick and ready to be laid with standard masonry techniques. The machines themselves can be built locally. In South Africa, the Department of Water Affairs and Forestry backed a project to develop mobile compressed earth block presses that could be transported to remote construction sites, allowing communities to produce blocks on location from local soil. The International Institute for Energy Conservation won a World Bank Award in 2002 for designing an energy-efficient version of the same concept. These aren't prototypes gathering dust in a university lab. These are working systems deployed across more than 50 countries, producing structural materials that meet or exceed building codes. What's unusual here is not the technology. Humans have been building with compressed earth for centuries. What's unusual is how completely this approach has been erased from mainstream construction knowledge in wealthy countries. The materials are superior, the costs are lower. The environmental case is unassailable. And yet, if you walk onto a residential construction site in the United States, you'll see wood framing and cement blocks, the same materials that have dominated for a century, unchanged. The gap between what's possible and what actually gets built is where this story turns. Because the issue isn't performance, it's economics. And it's the same pattern you've already seen with earth-sheltered homes and biorock construction. An industry built around specific materials doesn't pivot just because something better exists. The cement and concrete sector pulled in over $47 billion globally in 2024. When you include ready-mix operations, precast products, and the broader construction materials supply chain, that number climbs past $1.8 trillion. Those aren't just revenue figures, they represent distribution networks, manufacturing plants, equipment fleets, supplier contracts, workforce training programs, and lobbying infrastructure that took decades to establish. Compressed earth blocks require almost none of it. No cement kilns operating at 2,700 degrees Fahrenheit. No limestone quarries, no coal-fired furnaces releasing carbon dioxide as a fundamental byproduct of the chemical reaction. The entire supply chain that cement depends on becomes optional when you can press structural blocks from the dirt under your feet. And that creates a problem for every company whose quarterly earnings depend on selling bags of Portland cement. Consider what happens when 1 ton of cement gets produced. The process releases roughly 1,800 pounds of carbon dioxide. Half of that comes from burning fuel to reach the temperatures needed. The other half comes from decomposing limestone itself. It's not an inefficiency that better engineering can eliminate. It's chemistry. You cannot make conventional cement without releasing that carbon. The global cement industry generated 1.6 billion metric tons of CO2 in 2022. If it were a country, it would rank as the 4th largest emitter on Earth, behind only China, the United States, and India. Compressed earth blocks sidestep this entirely. You add 4 to 8% Portland cement as a stabilizer if you want extra moisture resistance and faster curing. Some builders skip it altogether and rely purely on mechanical compression. Either way, the embodied energy drops to 15 to 25% of what a fired brick requires. No kiln, no combustion. Blocks cure in sunlight and air. The emissions difference isn't marginal, it's structural. And the cost difference follows the same pattern. In Oroville, India, builders tracked expenses across multiple projects and found that finished compressed earth block masonry costs 15 to 20% less than conventional fired brick for the same volume. That's after accounting for labor, materials, equipment, and curing time. The Mexican social enterprise Échale has built 30,000 homes and renovated another 220,000 using compressed stabilized earth blocks, which they market as EcoBlock. The model works at scale across 28 states in climates ranging from arid desert to tropical humidity. These aren't experimental builds. They're housing developments serving hundreds of thousands of people. The machines aren't exotic either. Manual presses that require no electricity have been operating since the 1950s. The Sinvaram, developed in Colombia as part of a social housing research program, was the first widely deployed steel manual press. It produced blocks that were denser, stronger, and more water-resistant than traditional sun-dried adobe, and it could be operated by 2 people with no technical training. Mechanized versions today produce 240 to 480 blocks per hour on minimal electrical input or diesel fuel. Companies like AECT have deployed these systems in more than 50 countries. The technology isn't waiting to be perfected, it's already working. So why isn't it here? Start with building codes. Most municipal codes in the United States are written with wood frame and cement block construction as the default. Compressed earth blocks aren't prohibited, but they're not standard either. That means builders need to navigate alternative compliance pathways, submit engineering reports, and often wait months for approval. Each project becomes a custom negotiation with local building departments rather than a routine permit application. The friction isn't insurmountable, but it's enough to discourage widespread adoption, especially when conventional materials get approved with a single form. Then there's the workforce. Contractors know how to work with wood and cement. They've been doing it their entire careers. Their suppliers stock those materials, their equipment is calibrated for those processes. Switching to compressed earth blocks means retraining crews, sourcing different equipment, and explaining to clients why their builder is proposing something unfamiliar. Most contractors won't take that risk unless a client specifically demands it. Insurance adds another layer. Underwriters price policies based on known failure rates and repair costs for standard construction types. Compressed earth blocks don't have decades of actuarial data behind them in the American market, even though they've been used successfully across Africa, South America, and South Asia for generations. Without that data, insurers either charge higher premiums or refuse coverage altogether. Homeowners end up paying more to insure a house that's demonstrably more fire-resistant, more disaster-proof, and longer-lasting than the wood frame alternative. The aesthetic objection comes up too. Compressed earth blocks produce walls with a distinct texture and color that varies based on local soil composition. Some people find that beautiful. Others expect the uniform appearance of painted drywall or vinyl siding. Homeowner associations and suburban developments often have covenants that restrict exterior materials to maintain visual consistency across the neighborhood. A compressed earth block home, even one that meets every structural and safety standard, might violate those rules simply because it looks different. None of these barriers are technical. The blocks perform, the buildings stand, the costs are lower. The carbon footprint is a fraction of conventional construction. What's missing is institutional support. The kind of support that wood and cement have enjoyed for over a century through lobbying, code development, workforce training, and supply chain investment. And that's where the story gets uncomfortable, because if compressed earth blocks became standard, if municipalities updated codes to streamline approval, if contractors receive training as part of standard certification programs, if insurance companies recognize the superior disaster resistance and adjusted premiums accordingly, the technology would spread fast. But every compressed earth block home is a home that didn't buy lumber, didn't pour a concrete foundation, didn't install drywall, and didn't generate the recurring maintenance revenue that keeps the construction industry profitable year after year. The Mexican social enterprise Échale understood this perfectly. Since its founding, it has delivered 250,000 housing units across 28 Mexican states using compressed, stabilized earth blocks, which it markets under the name Eco-Block. These aren't experimental dwellings or demonstration projects. They're full-scale homes built for families who need shelter now, not in 10 years after the construction industry decides to update its supply chains. Each home proves the same point. The material works, the process scales, the cost drops. In Oroville, India, builders have documented that a finished cubic meter of compressed earth block masonry costs 15 to 20% less than country-fired bricks. That price advantage exists even after accounting for the learning curve, the equipment investment, and the lack of established supply networks. Once those networks exist, once contractors stop treating every compressed earth block project like a custom research experiment, the cost gap widens further. South Africa's Department of Water Affairs and Forestry officially recognizes compressed earth blocks, which they call Dutch brick, as an appropriate technology for a developing country. In 2002, the International Institute for Energy Conservation won a World Bank Development Marketplace Award for designing an energy-efficient mobile brickmaking machine that could be transported to rural sites, allowing communities to produce blocks on-site from local soil. The machine reduced housing costs while stimulating local building industries. It didn't require importing materials. It didn't depend on centralized manufacturing. It turned dirt into shelter using equipment simple enough that communities could operate and maintain it themselves. That's the pattern that keeps surfacing. Everywhere this technology gets deployed at scale, it works. Everywhere it remains inaccessible, the barriers are institutional, not technical. The performance characteristics make the institutional resistance even harder to justify. Compressed earth blocks, when properly made, achieve compressive strengths that rival or exceed conventional materials. Standard concrete blocks are rated at 1,900 pounds per square inch. Compressed earth blocks regularly hit several thousand pounds per square inch. One sample tested at an abnormal 45 megapascals, which converts to 6,500 pounds per square inch. That's not weaker construction, that's stronger. The blocks are fireproof, they're bulletproof, they're soundproof. They resist insects, mold, and moisture when stabilized correctly. A wall built from compressed earth blocks doesn't just meet building codes, it exceeds the performance of wood frame construction in nearly every category that matters for long-term durability and disaster resistance. And here's what makes the accessibility argument unassailable. Engineers who have tested soil samples across different regions find that roughly 65% of all soils are suitable for compressed earth block production. You don't need special clay deposits. You don't need to import aggregate. The material is beneath your feet. A small work team can produce all the blocks needed for a home within 2 to 3 days using a mechanical press. After manufacturing, the blocks cure for anywhere from 7 to 28 days, depending on whether they're stabilized with a small percentage of Portland cement. Once cured, they're completely water-resistant and ready to use like standard masonry. The production process requires a fraction of the energy needed for fired bricks or cement blocks. Fired bricks must be heated in kilns. That process consumes enormous amounts of fuel and releases carbon through combustion. Compressed earth blocks are pressed at room temperature and dried naturally by sun and wind. The embodied energy of a compressed earth block is 15 to 25% of an equivalent kiln-fired brick. If you're serious about reducing construction's carbon footprint, this is where the reduction happens. Not through marginal efficiency improvements in cement kilns, through eliminating the kiln entirely. The history of this technology stretches back further than most people realize. The first attempts at mechanically compressed earth blocks were made in early 19th century Europe. An architect named François Cointreau used hand rammers to compress damp soil into small wooden molds. The blocks were crude by modern standards, but the principle was sound. By the 1950s, a Colombian research program aimed at improving social housing developed the Kinvaram, the first steel manual press produced anywhere in the world. It created blocks that were regular in shape and size, denser and stronger than traditional sun-dried adobe, and significantly more water-resistant. Since then, laboratories across Africa, South America, India, and South Asia have refined soil testing procedures, press designs, and stabilization techniques. What began as vernacular building practice has been systematically engineered into a construction system with recognized standards. In multiple countries, compressed earth blocks are no longer alternative materials. They're code-compliant, proven, and deployed at commercial scale. The question isn't whether the technology works. It does. The question is whether the American construction industry will allow it to compete on equal terms. Right now, it doesn't. The permitting process is slower. The workforce isn't trained. The insurance industry charges higher premiums for unfamiliar materials, even when those materials demonstrably outperform wood in fire and wind resistance. Homeowner associations restrict aesthetics to maintain uniformity, blocking compressed earth block homes that don't match the vinyl-sided template. None of that is accidental. It's the result of a century of institutional investment in wood and cement. An investment that continues to pay dividends every time a homeowner finances another wood frame house, every time a contractor orders another truckload of lumber, every time a natural disaster levels a neighborhood and the rebuilding cycle begins again with the same materials that failed the first time. The soil is still there. The presses are manufactured and available. The science is settled. What's missing is the political will to treat compressed earth blocks as anything other than exotic. And that won't materialize as long as the industries profiting from conventional construction control the conversation. The homeowner paying to rebuild after a wildfire deserves to know this option exists. So does the family choosing between heating bills and groceries every January. The material that could shelter them affordably and permanently is already under their feet. The dirt under your feet has been building material longer than cement has existed. The physics work, the economics work. The buildings stand in 50 countries across climates that would destroy conventional construction in a decade, and the American construction industry has spent a century ensuring you never heard about any of it, not because the technology failed, because it succeeded in the wrong direction. Every compressed earth block home built is revenue the lumber mills don't collect, cement they don't pour, maintenance contracts they don't renew. The barrier was never technical, it was financial. And now you know exactly what they spent 100 years making sure you wouldn't ask about. The ground hasn't changed, the chemistry hasn't changed. What changed is that someone finally told you it was there.